Hello everyone, this is Kader Al-Rashidi. In this video, we will be conducting a digital version of our second craft training for the year 2024. The title of this craft training is as shown, Downhole Field Operations Basic. This training is intended specifically for our crew in downhole department and generally for all Al Khoreif Wafra Joint Operations employees. This training will help us get a basic understanding on what we are involved in and why we take all the necessary steps to be successful in it. However, it is a good idea to start our session with a safety moment. This is to remind ourselves about the importance of safety in our workplace. Please watch this short video courtesy of the Workplace Safety and Health WSH Council of Singapore.
Hello.
My name Arun.
I'm Yung Wei.
Dong Wei. Sleeping bed.
Make sure your safety equipment is in good working condition.
If you see anything unsafe, make sure you report to me or your supervisor, okay? I want everyone to be safe.
哎妈，我的几个哥们儿都挺照顾我的。呐。
Hello, Don't worry, we taking good care of your son.
Guys, football, 5 people, we join. Go. Yung Wei, football, we join.
I can, yes.
Yeah, we join.
You cook? Yes.
Your dog getting better. Hey, wait. Must stay safe.
Okay, thank you, Arun.
Aaron, look, go quick. I think no safe. Must report.
Arun, everything ready? Can start.
Okay, start work.
Okay, done.
Yong Wei,
Yes.
give me one tape.
Aaron, be careful.
Where's your way? What happened? What happened to you?
Sorry, Ai. Sorry.
Aaron, look, go quick. I think no safe. Must report.
You're right. Let's report. Boss. Want to report problem, sir? This one not safe.
Here in Wafra, we all come from different backgrounds and cultures. However, all of us have one thing in common. We all left our homes and families to come and work in this place. We spend half, if not more, of our day working with each others. We are a family, brothers, but not in the traditional sense. Looking for each other's back and taking care of each other's is what makes us brothers. Please make sure to always work safe and never cut corners. Please make sure to practice your stop work authority anytime you feel the need to do so. Never under any circumstances the management or the supervisor will blame you for reporting any unsafe act or condition. Always be cautious. Always be safe. Now let's start by going through the outline of this video. First, we will have a brief look about geology. What is it and why is it important? Second, we will look at drilling and casing operations. Third, we will look at the differences between drilling and workover onshore rigs. Fourth, we will have a brief look at the API standard, what it represents and why is important. Lastly, we will go through APC ESP standard operating procedure. In the end of this video, if you have any questions or doubt, please post it in the comment section below or add it in the Tech Hub WhatsApp group. Let's start by exploring a fundamental aspect of our work, geology. What is it? Why is it important? And how does it affect our day-to-day operations? Geology, simply put, is the study of the Earth. It encompasses everything from the materials that make up the Earth's formations to the processes that shape its physical structure. In essence, geology is a broad and comprehensive science that helps us understand the very ground beneath our feet. Understanding the geology of the field you are working in is crucial. It provides insights into the characteristics of the field, which is essential for making informed decisions. Each field has unique geological characteristics, and these differences have a direct impact on our equipment and operations. For instance, the type of rock formations, their stability, and the presence of certain minerals can all influence the choice of equipment we use, the techniques we apply, and the overall strategy for extraction and maintenance. Therefore, having a fair understanding of geology helps us optimize our operations, improve safety, and enhance efficiency. In summary, geology is not just an academic subject. It is a practical tool that underpins our work in the oil and gas industry. By appreciating and applying geological knowledge, we can better manage the challenges and opportunities that come with each unique field. Let us dive deeper into this topic. This is a depiction of Kuwait City. You can see the cityscape framed by the golden sands of the desert and the blue waters of the Arabian Gulf. Kuwait's environment is extremely harsh, with summer temperatures soaring up to 55 degrees Celsius, and winter temperatures occasionally dropping as low as -4 degrees Celsius. However, beneath this challenging climate lies a blessing from God: reservoirs of hydrocarbons. These hydrocarbons, primarily oil and natural gas, are crucial for the development and progress of mankind. They power industries, fuel transportation, and play a vital role in the global economy. Now let's talk briefly about hydrocarbons before we dive deeper into our subject. What are hydrocarbons? Hydrocarbons are organic compounds that contain only carbon and hydrogen atoms. They are the main components of fossil fuels such as petroleum, natural gas, and coal. Hydrocarbons are classified into different types based on their chemical structure: alkanes, paraffins; saturated hydrocarbons with single bonds between carbon atoms, for example methane and ethane; alkenes, olefins; unsaturated hydrocarbons with one or more double bonds between carbon atoms, for example ethylene and propylene; alkynes, unsaturated hydrocarbons with one or more triple bonds between carbon atoms, for example acetylene; aromatics, hydrocarbons containing one or more aromatic rings, for example benzene and toluene. Hydrocarbons are essential for modern society, providing a primary source of energy and serving as raw materials for a wide range of industrial products. Let us continue with our topic. Here we can see a virtual cross-section of what's underneath the golden sands of Kuwait. In this cross-section, you can clearly see various layers of different shapes, thicknesses, and colors. While this image may not be entirely accurate or true to life, it represents the geological complexity of the Earth's subsurface. Each of these layers has its specific properties, such as pressure, porosity, permeability, and more. Understanding these properties is crucial for our operations. For instance, pressure, the force exerted by the weight of overlying rock layers and fluids within the pores. Porosity, the measure of the void spaces in a material, which affects how much fluid a rock can hold. Permeability, the ability of a rock to transmit fluids through its pore spaces. These properties significantly impact our extraction techniques and equipment choices. Recognizing the unique characteristics of each layer helps us optimize our operations and ensure the efficiency and safety of our activities. Now that we understand the properties of the various geological layers, let's delve into the specific types of rocks that play crucial roles in hydrocarbon formation and trapping. By examining source rocks and cap rocks, we can better appreciate how oil and gas are generated and preserved in the subsurface. Source rock. Source rocks are the geological formations where hydrocarbons originate. These rocks are typically rich in organic material which over millions of years gets buried and subjected to heat and pressure. This process, known as maturation, transforms the organic material into hydrocarbons, primarily oil and gas. Common source rocks include shale and limestone, which contain high levels of kerogen, the precursor to oil and gas. Cap rock. Cap rocks play a crucial role in trapping hydrocarbons in the subsurface. These impermeable layers, often composed of materials like claystone, shale, or anhydrite, lie above the reservoir rock. They act as seals, preventing the upward migration of hydrocarbons and allowing them to accumulate in the reservoir. Without effective cap rocks, oil and gas would escape to the surface and disperse. Gas and oil. Hydrocarbons are typically found in two primary forms, oil and natural gas. Oil. Formed from the remains of ancient marine microorganisms, oil is a liquid hydrocarbon. It varies in composition, ranging from light, volatile oils to heavy, viscous crude. Oil is a vital energy source and raw material for numerous products, including fuels, lubricants, and petrochemicals. Natural gas. Composed mainly of methane, natural gas is found in association with oil or in separate gas reservoirs. It forms under similar conditions as oil, but can also derive from organic matter subjected to even higher temperatures. Natural gas is a cleaner burning fossil fuel, widely used for heating, electricity generation, and as a feedstock for chemical industries. Understanding these elements is essential for effective exploration and production. Source rocks generate hydrocarbons, cap rocks trap them, and the resulting oil and gas are extracted to meet global energy demands. Each of these components must be carefully studied and managed to ensure successful and sustainable hydrocarbon production. Now let us explore something more familiar to us. Here we can see the stratigraphic column of Kuwait. A stratigraphic column is a visual representation of the vertical sequence of rock layers, strata, in a specific location. It is a fundamental tool used in geology to illustrate and study the chronological order, thickness, and characteristics of different geological formations. By examining this stratigraphic column, we can gain valuable insights into the geological history of the region, identify potential hydrocarbon reservoirs, and understand the structural features that influence fluid flow within these formations. This knowledge is crucial for effective exploration and production in the oil and gas industry, as it helps us make informed decisions about drilling locations, extraction techniques, and resource management. Zooming in Kuwait's stratigraphic column, we can see formations and reservoirs we are producing from here in our operations in Wafra, for example. We can see Eocene Formation, which is mainly represented by letter S in our well operations. We can see Maastrichtian Formation, which is mainly represented by letter M in our well operations. We can see Wara Formation, which is mainly represented by letter W in our well operations. We can see Ratawi Formation, which is mainly represented by letter R in our well operations. These formations are integral to our production activities, and understanding their characteristics helps us optimize our extraction techniques and manage our resources efficiently. Furthermore, a question may be raised: how did geologists and scientists know about this stratigraphy? How did they determine the formation's petrophysical properties and mineralogy? All of this is done by taking a coring sample. A coring sample, also known simply as a core, is a cylindrical piece of rock extracted from the subsurface during drilling operations. This sample is obtained using a specialized tool called a coring bit, which is attached to the drill string. The core is typically taken from the reservoir rock or other geological formations of interest. This core sample is used to understand reservoir characterization, petrophysical properties, mineralogy, geological and structural analysis, stratigraphy, structural features, fluid analysis, hydrocarbon content, fluid properties, economic evaluation, resource estimation, and more. By providing a direct and tangible sample of the subsurface rock formations, coring samples play a vital role in the exploration, evaluation, and production of oil and gas resources. They enable more precise and informed decision-making, leading to better management and optimization of hydrocarbon reservoirs. Now let us move on and explore the drilling operations. After a seismic reflection survey, which is a specialized job that uses non-invasive geophysical techniques, geoscientists can image geological features and structures throughout the whole thickness of the crust. In a simple form, this survey provides an indication of whether hydrocarbons might be present in a particular location. After the seismic data is interpreted, the reservoir engineer, along with the geologist, evaluates the potential for hydrocarbon presence in the surveyed area. They analyze the seismic reflections to identify possible reservoirs, determine their extent, and assess the likelihood of hydrocarbon accumulation. Based on the depth of the reservoir, its location, geometrical complexities, and the depth that needs to be drilled, a drilling program is created by the drilling engineer. A drilling rig then moves to the location and begins the drilling operation. While well drilling might seem as simple as removing dirt from the ground until reaching the desired depth, it is in reality more about constructing a well rather than merely drilling a hole. This involves careful planning, casing, cementing, and installing various equipment to ensure the well's integrity, safety, and efficiency. Let's zoom in and take a closer look at a simple overview of drilling operation. It starts by drilling the surface casing hole, conductor casing in some regions. This is generally done to protect the freshwater aquifers by placing a steel and concrete barrier to isolate the water table from the well. Protect the well from the aquifer, water cuts of the drilling fluids with fresh water. Protect the well from shallow gas hazards. After drilling the first section, a casing is installed and cemented to the annuals of the well to isolate the formation from the next section. The process continues to drill to the next predetermined casing point, which is called intermediate casing. This is generally done to isolate unstable hole sections, isolate under pressured zones to prevent loss of circulation, isolate over pressured zones to prevent well kick, isolate multiple production zones. Continue the process to drill the total depth TD. Once the final intermediate casing string is run and cemented, the drilling process is continued until the well reaches the TD of the well. After that, the production casing or liner is run and cemented. After running and cementing the production casing or liner, a perforation job is conducted on the production casing. Perforation involves running a perforation gun into the wellbore until it reaches the desired production depth. Once in position, the perforation gun is fired to create openings in the casing, allowing reservoir fluids to flow into the casing. After perforation, production tubing is installed in the well. Following this, a series of valves and equipment, known as a Christmas tree, is installed on top of the well. The Christmas tree controls the flow of formation fluids. In wells where the formation fluid flows naturally to the surface, this setup is referred to as a natural flow well. However, if the flow of the fluid is not sufficient to reach the surface naturally, the well requires additional means to assist the fluid in reaching the surface. In the oil and gas industry, this process is known as artificial lift. One of the most widely used artificial lift methods is the electrical submersible pump, ESP. An ESP is a technology installed in the well to help increase the lift of the fluid, enabling it to reach the surface. The ESP system consists of a multi-stage centrifugal pump that is submerged in the wellbore. It is powered by an electric motor, which drives the pump to lift the fluid from the reservoir to the surface. The key components of an ESP system include pump, a multi-stage centrifugal pump designed to handle large volumes of fluid. Motor, an electric motor that drives the pump, typically located below the pump in the well. Seal section, protects the motor from well fluids and provides a pressure equalization system. Power cable, transmits electrical power from the surface to the motor. Surface controls include transformers, switchboards, and variable speed drives to control the ESP's operation. ESPs are particularly effective in wells with high production rates and can handle a variety of fluids including oil, water, and gas. They are known for their efficiency and ability to operate in harsh, downhole environments. By installing an ESP, operators can significantly enhance the production capabilities of a well, ensuring a steady and reliable flow of hydrocarbons to the surface. Now let's proceed to examine the drilling operations. In the oil and gas industry, there are both onshore and offshore rigs. Since we operate exclusively in Wafra, let's focus on onshore rigs. Onshore rigs can be categorized into two different types. Drilling rigs. These rigs are used to drill new wells. The main tasks involved include drilling the well, installing casing to stabilize the wellbore, cementing the casing to secure it in place, completing the well to prepare it for production. Drilling rigs are designed to handle substantial stresses and the complexities of drilling operations. Workover rigs. These rigs are used for well maintenance and servicing. Their main tasks include cleaning the wellbore to remove debris and obstructions, repairing or replacing damaged casing, pulling out and installing downhole equipment such as pumps and tubing. Workover rigs are less robust than drilling rigs and are specifically designed to handle well servicing operations. We will focus on workover rigs for now since drilling rigs are not within the scope of our work. A workover rig contains the following main components: mast or derrick, drawworks, power system, pump, rotary table or top drive, pipe tubing handling system, blowout preventer BOP, mud system, cranes and catwalk. The mast, also known as the derrick, is a tall vertical structure that provides the necessary height to handle long lengths of pipe and tubing. It supports the weight of the drill string and other downhole equipment, facilitating the raising and lowering of pipes, tubing and tools into and out of the wellbore. Masts are typically designed to be collapsible or foldable for easier transportation and setup at different well sites. They are constructed from high-strength steel to withstand substantial loads and operational stresses. The top of the mast houses the crown block, a fixed assembly of pulleys, while the traveling block moves up and down within the mast. This system, in conjunction with the drawworks, provides the mechanical advantage needed to lift heavy equipment. The base of the mast, known as the rig floor, is where operations are conducted. It includes the rotary table or top drive, and is the central point for pipe handling. The mast is equipped with various safety features, such as guy wires or supports, to ensure stability during operations, especially under high wind conditions or heavy loads. Rig centering is a crucial aspect of the installation process for electrical submersible pump (ESP) equipment. Proper centering ensures that the entire operation runs smoothly, efficiently, and safely, preventing potential damages to the equipment and enhancing the overall performance of the ESP system. There are many factors that contribute to the rig centering: uneven ground surface, soil stability, the load of the equipment and tubing increases with higher depths, environmental factors such as strong wind, heavy rain, or seismic activity. Now that we have thoroughly discussed the importance of the mast in a workover rig, let us shift our focus to the other crucial components that enable the efficient operation and maintenance of oil and gas wells. Each of these components plays a vital role in ensuring the overall functionality and safety of the rig during various workover operations. The drawworks is the hoisting mechanism of the rig, consisting of a drum, brakes, and a power source. It is responsible for raising and lowering the drilling or servicing equipment into and out of the wellbore. The drawworks provides the necessary mechanical advantage to handle the heavy loads encountered during well operations, making it a critical component for the smooth functioning of the rig. The power system typically includes diesel engines or electric motors that generate the energy required for all rig operations. This system powers the drawworks, pumps, and other essential equipment, ensuring that the rig can perform its tasks effectively. Reliable power systems are essential for maintaining consistent operational performance and minimizing downtime. The pump is used to circulate fluids within the wellbore during cleaning, repair, or completion operations. It plays a crucial role in maintaining well control, removing debris, and ensuring the proper placement of cement or other materials. Pumps are designed to handle various types of fluids and operate under different pressure conditions, making them versatile tools in workover operations. The rotary table or top drive is responsible for rotating the drill string or tubing, facilitating various downhole operations. The rotary table is a fixed piece of equipment located on the rig floor, while the top drive is a mobile unit that can move along the derrick. Both systems provide the necessary rotational force to drill, ream, or perform other mechanical tasks within the wellbore. The pipe tubing handling system includes elevators, tongs, and slips used to handle and manipulate the pipe, tubing, and other downhole tools. It ensures the safe and efficient movement of these components during installation, removal, or maintenance operations. Proper handling systems are essential for minimizing damage to equipment and ensuring the safety of personnel. The blowout preventer, BOP, is a critical safety device installed on the wellhead to prevent the uncontrolled release of well fluids. It can seal off the wellbore in case of a blowout, protecting both the rig crew and the environment. BOP are equipped with multiple rams and annular preventers to provide a robust barrier against high-pressure formations. The mud system comprises tanks, pumps, and mixing equipment used to prepare and circulate drilling fluids, mud, during operations. These fluids help control wellbore pressure, stabilize the formation, and remove cuttings from the well. A well-maintained mud system is essential for maintaining well control and ensuring efficient drilling and completion processes. The catwalk is a structural platform that serves as a staging area for pipe and other equipment before they are lifted into the rig. The catwalk is typically located at ground level and runs parallel to the rig floor. It plays a crucial role in the safe and efficient handling of tubulars and other tools used in well operations. Now let's move forward to explore the API standards and their significance in the oil and gas industry. The American Petroleum Institute, API, established in 1919, plays a crucial role in the oil and gas industry by developing standards that ensure operational safety, efficiency, and environmental protection. These standards are globally recognized and widely adopted, influencing international regulations and promoting best practices across the industry. By adhering to API standards, companies can enhance their operational reliability and minimize environmental impact, making API a cornerstone of industry excellence. API standards cover crucial areas in the oil and gas industry, including drilling, production, refining, pipelines, and health, safety, and environment, HSE. In workover operations, API standards ensure the reliability and safety of critical components like electrical submersible pumps, ESPs, and production tubing and casings. For example, API Spec 5CT specifies the requirements for casing and tubing, essential for maintaining well integrity during production. API RP 11S provides guidelines for the design, installation, and operation of ESP systems, ensuring their efficient and safe performance. Additionally, API Spec 11AX outlines the specifications for subsurface sucker rod pumps and fittings, which are critical for various artificial lift methods, including ESPs. By adhering to these standards, operators can enhance the performance and longevity of well components, ensuring safe and efficient production. Now let us take the casing, for example. The inner diameter, ID, the outer diameter, OD, the drift, and the weight of the casing is all standardized using the API standard. This is important to provide guidelines and best practices that help prevent accidents and protect workers, equipment, and the environment. Lastly, Al Khorayef Petroleum Company has created and implemented its own standards and procedures for handling all equipment and tools within their work scope. These standards and procedures are aligned with API standards to ensure that the quality of the equipment meets international benchmarks. All of this is done by implementing a quality management system, QMS. QMS is essential for maintaining consistent quality across all our processes. It ensures that we deliver reliable and high-standard products and services every time. It provides a structured framework for documenting and reporting our procedures, which is crucial for transparency and accountability in our operations. And by adhering to industry standards such as ISO and API, a QMS enhances our credibility and ensures we meet all regulatory requirements. 1A QMS also plays a significant role in enhancing customer satisfaction and loyalty. 2. By consistently meeting or exceeding customer expectations, we build trust and long-term relationships with our clients. Furthermore, a QMS helps identify and eliminate inefficiencies in our processes. This reduces waste and operational costs, leading to more efficient operations. It also promotes a culture of continuous improvement. By regularly updating our processes based on performance data and feedback, we can continuously enhance our operations. Lastly, a QMS is crucial for risk identification. It helps us identify potential risks and implement measures to mitigate them, ensuring smoother and safer operations. In summary, a quality management system is vital for ensuring quality, compliance, efficiency, continuous improvement, and risk management in our operations. Let us quickly go through the QMS documents index used by Al Khorayef Petroleum Company in their joint operations project in Wafra. This document index covers the project quality plan, inspection and test plan, and all the standard operating procedures and work instructions related to processes done within APC WJO ESP work scope. Here we can see the SOPs and WI related directly to the downhole department. Procedure for ESP operations. Procedure for inspection and testing of ESP cable. Procedure for ESP cable splicing. Procedure for ESP handling and downhole assembly. Procedure for ESP run-in hole. Procedure for pull out of hole and lay down. Procedure for Y-tool bypass system. Procedure for discharge pressure line installation. And work instruction for Y-tool inspection and blanking plug redressing. Work instruction for water well installation. Work instruction for water well pullout. Work instruction for shroud assembly. APC QMS documents can be found in Wafra Workshop Training Room as a hard copy. Requesting soft copies from the QA/QC or your supervisor. by accessing Downhole Department SharePoint under the Quality Hub section. We've reached the end of our talk. Please share your thoughts or any questions in the comments section or the Tech Hub WhatsApp group, and we'll respond promptly. Thank you for listening. This training session is just a starting point, introducing crucial topics in our work. Mastery requires self-study and initiative. Check the websites I'll add to the video to expand your knowledge.